Okay, so hello everyone. Can you guys give me a confirmation if my voice is audible or not? Okay, guys, so I guess it's audible over there. Uh, so, uh, so this is the session, the second day of machine learning using TensorFlow. As welcome. I will be welcoming you all to the session. And yesterday, that was on 14. We had the day one, and I was like, we were really surprised and we are really excited to see all your that you all are really interested in this field, and you like because we stayed for at a straight for 3 hours, and we learned the new stuffs, and today it's going to be more exciting than that was yesterday, because it's about neural networks. So are you guys excited? Can I have the replies, please? So, are you guys excited for today? Okay, cool. So, I can see you all are really interested for this session. So, let's keep the session let's keep this what you can say, keep this enthusiasm till the end. And we will be trying that. Will try to make you understand all the concepts in the short time. Like yesterday, we will try not to extend it. Can anyone out there tell me what are the concepts we learned yesterday? We need to revise it up before we move to today's agenda. So yes, can anyone list? Yes, definitely. Yeah, sure. Yeah, tomorrow is the last day of the event. So after that, we'll be sharing all the recordings and all the materials with you all. So yeah, can anyone share what are all the things we learned yesterday? Okay, so we have reply from Nishakant Parida, scaling, outlier removal, data representation. Yeah. Uh, has Nishikant missed anything, or will you guys like to add something to whatever he has written, or you agree with this? Like we read this much, or you guys want to add something extra to this? Maths behind, yeah, exactly. Maths behind logistic regression. Anything more? Scaling, outlier removal, data representation, maths behind logistic regression. Anything is there anything which we are missing on, guys? Come on, guys, you need to reply to me. This is going to be a two-way interaction session. It's not just going it's not just going to be we will be teaching and you will be sitting there just is there anything we are missing over here? Applications of women. Okay, yeah. So that was all we learned yesterday, I guess. Yeah, oversampling. We learned all of these concepts yesterday. I already shared the notebook with you, and in case some of you are not still aware of that of the use of Google Collab, I will just be revising what we learned yesterday. Not specifically revising, I will just be pointing out all the things we learned yesterday within 5 to 10 minutes, and then we'll be moving to today's agenda, that is deep learning. Deep learning will be learning a bit about deep learning, like why at times it is preferred over ML. You guys remember deep learning, right? We saw that Venn diagram of artificial intelligence, deep learning, data science. So can anyone tell me what is deep learning? Okay, subset of ML. We have one reply. It's a subset of ML. Anyone wants to add something to that? Okay, so we'll be moving to deep learning today. We'll be learning the concepts of neural networks, and we took a data set. Which data set it was? Which data set we used yesterday? Bank chain. Okay, yeah, right, Pratyush. We took the bank chain data set, so we'll be taking the same data set, and we will be seeing how the application of DL changes the accuracy. So let me share my screen. Uh, Can you give me the confirmation my screen is visible or not? Okay, fine. I guess it's visible. Okay, fine. So moving to the collab, I have already told you this is the Google collab, and we'll be walking over here to if you want a short introduction on Google collab, let me just. Google Colab is basically it's not a static web page, and it's an interactive environment, and we can execute it. It is something which allows us to write and execute our Python codes in the browser itself. I already mentioned, we don't need to we don't need to install some software. It's just in, we have Google, and we can just search Google Colab, and we can get it. So this is what we worked on like yesterday. So we worked on the bank churn modeling, data set. So we click here, and it directed us to the Kaggle site, and from there we downloaded the churn modeling data set, and by clicking over here we uploaded the data set. I guess you guys remember all this. So let us upload the data set again. We imported data like the churn modeling data. We stored it in a variable. We carried the data information process. We carried the data information. Uh, in the data information part, we carried out certain steps. We tried to know more and more about our data by using data.save, data.columns, and all the things. Then data pre-processing, we selected some columns, like we dropped some of the insignificant columns. We then moved towards checking if there are null values or not. And I had already told that we are lucky enough that there were no null values in our data set. And then we moved to exploratory data analysis. Can anyone mention in the chat what is the main reason of using exploratory data analysis? We are going through a quick revision. So and this all things we learned yesterday. So you guys need to reply to me. What is the main motive behind EDA, that is exploratory data analysis? What's the use of exploratory data analysis, EDA part? EDA is basically we made. If you guys remember, we tried plotting the count plot, the pie chart, and all that. So what's the use of that? To help customers understand. Okay, we have reply from Sakti Bishwal, to help customers understand. Is there any other need of EDA? Knowing the feature importance, yeah. Okay, so basically EDA, to find patterns in trade. Yeah, perfect. So we basically need to know the hidden aspects of data, and EDA is something which helps us understand it. So let's be really quick so that we can move towards agenda. So we move to the EDA part. We came to know about the univariate analysis, bivariate analysis, multivariate analysis. We came to know about the box plot, and the box plot is used for box plot is a part of EDA, but it helped us in feature engineering also. So box plot, how did box plot help us in feature engineering? Outlier detection, yeah. Summarizes data, outlier detection, yeah. Perfect. Then we know. Then we knew about the interquartile range, the 25th percentile, the 75th percentile value, and then we removed the outliers. Then we did the encoding thing, so that we could convert our categorical variables, which were in string format, to numbers. Then we can oversampling was there. So the oversampling was there so that we could balance our imbalanced data set. And then we finally carried the scaling, and then we made use of standard scaler. Then finally we moved to a machine learning model, and which algorithm we made use of in machine learning. yesterday. Which algorithm we made use of? Logistic regression. Yeah, because right. Logistic regression. Yeah, Durga, we discussed about linear regression, like Lakshman explained it about it, but in the notebook we made use of logistic regression. So yeah. So that was what we learned yesterday. We pretty much you guys must be proud of yourself, like you learned a lot of things yesterday. We like you understood each of the codes and learned new techniques, and you're still answering me and you guys remember it till now. So yeah, you should be proud of yourself. So we pretty much completed it till here. So you, what you can do for those who don't know like how to run the cells, if anyone is there like that, I'm just telling you, you just need to open the link I have shared with you. Then use you need to go over here, then click here, and you will be loading the data set, which can be downloaded by clicking here. It will be directing you to another website, that is Kaggle, and from there you can download the Chen modeling. And if you want to execute this cell, you can just click over here and it will be executed. So likewise you can execute this cell. So that was all about the revision of yesterday. We like learned all this thing yesterday. It was, I think it was necessary for you to remind you all this, because some way or the other this will be necessary for us today. And today we'll be moving to deep learning, so I won't be taking any more time like revising the earlier concept. So today's agenda, as I have already mentioned, it will be more about deep learning. We'll be focused on neural network. We will come across a term known as TensorFlow. We'll be explaining it to you in details, and then we will be understanding why at times deep learning, that is DL, जिसको हमने थोड़ा बहुत वेन डायग्राम के टर्म्स में एक्सप्लेन करके छोड़ दिया था, we will be explaining it to you in details. We'll be providing the whole intuition behind it, and we will be telling you why at times DL is preferred over ML. And you will be seeing ये जो accuracy हमारा 73% आया था इस बैंक चैन मॉडल में, you will be seeing deep learning यूज करने पर ये accuracy कैसे improve करता है. So basically, summing it up, we'll be first understanding the theoretical part. Then we'll be whatever we understand in theory, we'll be applying it into our Chern modeling. So to move to our coding part, you will have to have some patience and you will have to wait, so that you can understand the theory. And in the end, we'll be moving to the coding part. And in between, we also have some fun event for you, but you need to kind of have patience and wait for that. Still then, you can just continue with the theory. Shuhag, I guess you can now take over the session and explain it to them about the deep learning.
Yeah, thank you.
Okay, fine. So let me just stop sharing my screen. So can you guys give me a confirmation? Are you all ready to get started with day two? Are you guys ready? Are you guys excited about day two? Okay, cool. Uh, you can now just get started, Suhag.
Okay, so hi guys, myself Suhag, and welcome back again to the second day ML event of our GDC Club OETB. So, what's the plan for today, right? So, today we are going to discuss more about the newer approach or newer algo called deep learning. So, before proceeding further, I want you guys to reply me what is deep learning? Means why you prefer deep learning over machine learning? Please put it in the chat box.
Basically, you guys have idea what is deep learning, as you have replied. It's a subset of machine learning. What we want to
Any
know,
basic knowledge? Yeah.
yeah, what we want to know. Do you know anything other than that? That despite that it's a subset of machine learning, and
Means why you prefer deep learning over machine learning?
yeah, like why we prefer deep learning over machine learning.
Yeah.
If anyone knows that, we will be explaining it to you. Like you don't need to
No,
worry if you
don't
don't
worry.
know,
I
but
have
we're just, yeah,
the
we're just
agenda is there
asking.
is no prerequisite. You will be fine with it.
Okay, so we have
Okay.
replies.
Yeah. Structure of brain. Yeah, fine. Great. There are great replies. So let me to explain it. So let me share my screen. So is it visible?
It's visible.
Okay, thank you. So we today we are going to discussing a new topic of data science, and a vast topic is typically known as deep learning. Okay, so in yesterday's session in machine learning we are talking about models, predictions, error functions, loss functions, and many more kind of things. But in machine learning world, wherever you go, either you go for computer vision, either you go for linear regression or classification, or NLP, that is natural language processing kind of thing, just like our human English can be understood by our computers like Google Assistant and Alexa kind of things. And either or you go for reinforcement learning. Everywhere we require this concept and this new approach. And the new approach I am talking about the deep learning concept. So till now we only discussed the machine learning. So let's take a problem like face detection model. Okay, the detection model can be solved by machine learning, and can be solved by deep learning. I want to say that the problem that can be solved with machine learning also can be solved with deep learning, but the vice versa is not true. Means the problem which can be solved with deep learning can't be solved with machine learning. So let's get started with the next part. Mm, so let's take the same example we take yesterday. The number of hours a student study and the marks he achieved. Let's say a student studied 2 hours, he achieved 20 marks. Again, another student, let's say, studied 4 hours and he get 40 marks. Again, let's say 5 hours, 50 marks, and in 7 hours, it is 70 marks. Okay, and if I ask any human being or ask you guys, if a student study 8 hours, so how many marks he gonna achieve? Okay, we humans are so smart that we can make a analyze kind of thing or make any pattern that we can tell. Let me. Okay. Yeah. So you human can predict and make a pattern until it's 80. But how computer works? So we know in computer there are some hardwares like CPU, RAM, or any input output, other input output kind of devices. And we typically human beings are known as users. So how we interact with hardware? There is a medium that is known as operating system. Okay, and also how we interact with operating system with some there are only two ways to interact with operating system. That is, one is file. Okay, and another one is your folder or directory. Okay, so there are only two ways to interact with the operating system. And what these files contains, these files contains some lines of code. Okay, and these lines of code follow some protocol or language kind of things, and it gives us output. Okay, so similarly, if I ask the computer how give me answer in 5, so computer gets search and give us output that is 50. If the output is present, it gives us output, or it is if the output is or answer is not present, it is throw an error. Okay, so this is the how computer works. But there is no kind of things that computer can predict or analyze the things. So what till now what we do or our research guys do, they only make a mimic of some of the things that already exist, just like our eye. And guys do the mimic, that is our webcam. Okay, in natural things we have voice, and the in computer system it's speaker. In human being we can hear through ear, and in computer system it's mic. Okay, so same thing to mimic the human brain. We are head over to a new topic known as artificial intelligence or machine learning, or typically the topic today is known as deep learning. Okay, so before going to deep learning, I want to tell you how yesterday session how machine learning actually work, and today I am going to tell you why we prefer deep learning over machine learning. So if we take the same example, okay, and put all this information in a graph. So this is my y-axis and this is my x-axis, and here I am in x-axis. I am taking the numbers of hours, and this is the marks. Okay, and the hours, let's say 2, 4, 6, 8, 10, up to anything. And in this axis, we are going to take mark like 20, 40, 60, 80, and 100. And if I put this point, this data to our point, so 2 hour 20 mark, then 4 hour 40 mark, then 5 hour 50 mark somehow here, and again 7 hour 70 mark. Okay. And how our traditional machine learning work, it only initialize with some functions, okay, or bias or weight we discussed. Then it keeping searching which function is getting get successfully override on these points. So it keep on searching, keep on searching, keep on, and then it throw a function that completely satisfies this point, and then we get a function, and this function is our typically is our model, or this function has some bias and weight. So these kind of things we discussed yesterday. Okay, so today we are now head over to our new topic called deep learning. So in machine learning work, what we do, we only create a model. Model means what? It's a mathematical function. Okay. So it's just a mathematical function. Mathematical function means there is a bias, but there is a weight, means a slope or constant kind of things. So so main motto of our machine learning is to find the bias and weight. There is two approach to solve these problems. There is a traditional approach and a newer approach. Okay, the traditional approach is typically the sessions we take yesterday. So newer approach is deep learning. So how traditional approach do? The traditional is like the guys, they're statistical things. Just like I told you in this graph, the line gonna match, and given function. In deep learning work, the work is done more like human being work or human brain work. Okay, human brain is just a more emphasis on the human brain. Before discussing the human brain, I want to explain why deep learning over machine learning. So before creating a model, we get a data set. Okay, this data set have some number of columns and some number of rows. Okay, so after getting data set and creating a model, we have some steps to do, just like feature selection. We have to choose which feature we're gonna take. Then our data cleaning. Then creating the model and model creating, testing, and finally deploy it to our model. But finally deploy to our real world. But I want to more emphasize on this feature selection part. Right. So in a student data set or any kind of data set, there are limited number of columns. Means there are 10 or 11 or 12 number of columns. So we can choose what is your prediction thing, and these columns are typically known as features or columns, and this y is typically known as dependent variable. Okay, means this y is depend on these columns, and these columns are typically known as independent variable. That means these columns are not dependent on any kind of data, or they are independent. So these columns are independent variable and these columns are dependent variable. But but there is some columns who won't affect this dependent variable, means our y or our prediction function. So we have to manually choose which column is to take and which is not to be. But here is the limit, that here is a norm, and the count things of norm means the limit of number of columns. But in real world or in corporator, there are million and billions number of columns. Okay, just like our image data set. In image dataset, there are millions of rows and millions of columns. We can't manually choose which column to take and which is not to be. And also in natural language processing, there is millions of columns. So we can choose out of billions columns which is going to take and which is not to be. So by this thing, but in deep learning, the feature selection is gonna very easy, because in deep learning feature we don't have to select the feature manually. Okay, because the feature selection is automated in deep learning. Okay, means I want to tell you that there is no need of feature selection in deep learning. So the um, um, we have first point why we prefer deep learning over machine learning is we don't require feature selection. Okay, this is the first point. And next, let's come to next point. Let's say I have a data set with many columns, and there are also many number of rows. Means I have a number of data or number of rows in my data set. So if I draw the machine learning graph, means our traditional machine learning graph, and I put the data to the, or give the data to our model. And if I in x-axis I take the number of data we take in a data set and the accuracy we achieve in, this is our machine learning or traditional machine learning graph. So if I see in traditional machine learning, as our data gonna the number of data gonna increase, the at still some certain point of time the accuracy gonna increase. Okay, let's say we have 1,000 number of data, and at some point like 600, the before 600 the accuracy gonna increase rapidly. After that point in machine learning, what happen, the number of data getting increases, but the accuracy is not gonna increase rapidly, it is gonna increase in a negligible way. Okay, so I feed the more and more data to the model, but the accuracy is not gonna increase. Okay, this is the drawback of machine learning or traditional machine learning. But in deep learning, if I draw again same graph for deep learning, okay. So in deep learning, if I try to draw same graph, here is number of data and here is accuracy. In deep learning, the as we increase the number of data, the accuracy gonna increase rapidly. As we feed number of data more and more, the accuracy is gonna increase more and more. But there is a certain limit points that it never reaches 100. Means let's say this is our 100 point. Okay, and our accuracy is never gonna reach 100. Means there is a, this is the limitation of our model, because we can predict a thing 100%. Okay, in machine learning world 100% means we there is, this model is wrong, means we can predict the whole thing accurate. Means you human being can't also predict the thing more 100% accurately. In machine learning world 85 to 90% accuracy is great. Okay, 90 to 95 also have, means this we do some wrong with this model, but our model is fitted our model is not fitted correctly. So we always have to find the accuracy between 85 to 90%. It's great for our model. Okay, so these are the 2 points why we choose machine learning over sorry, deep learning over machine learning. Okay, again, if I took another example of data set, let's say I have a data set of diabetes, okay, and there are many number of columns. and this final column is y, which will predict a person have diabetes or not, and these columns having like blood group column or sugar level column, many kind of medical report. Okay, so I am a pure machine learning guy or data science guy. I don't know about this blood group, sugar level, and any kind of medical science kind of thing. So if I try to choose which column is to take, which column is not to take, so I should take help of this domain, should take help of a person who is belonging to this domain. Means I want to take help uh, uh, from a person who is expert in medical science, and this expertise person is typically known as domain expert. Means they are expert in their domain and they are going to help us in this kind of data set. And in that diabetes data set or medical kind of data set, our domain expert is doctor. Okay, so we can take help of a doctor, um, and to choose which feature is going to take or which is not to be. Okay.
Okay, so adding on to this, as Suhag said that the domain expert, while we are doing the feature selection for us, it's the doctor over here. But yesterday we worked on the Chun prediction data set, right? So can you guys tell us like who must be the domain expert for our Chun prediction data set? Any guesses works. Like we are not expecting, we are not judging you, or we are not giving you some marks over here. So whatever comes to your mind, you can like give it a shot. Like he told you now, like deep learning is preferred over machine learning because mainly of two reasons. One is the feature selection is automated in case of deep learning. We like the way we dropped the insignificant columns over here, we selected certain features, so that was the feature selection. Second, when the data points are more, deep learning plays a better role. So moving forward, he like Suhag explained it very well that in while feature selecting, while doing feature selection, our domain expert is for the diabetes data set. For feature selection of features, the domain expert is doctor. So what we are asking you is, डायबिटीज डेटा सेट के लिए तो डॉक्टर था डोमेन एक्सपर्ट, हमने कौन से डेटा सेट में काम किया था? लाइक यस्टरडे we sat for 3 hours, we worked on the Chun prediction, bank Chun prediction data set. So okay, we have a reply. Account or bankers. Okay, we have reply from Arijit Mohanty, accountants or bankers. Then Biraj Raj Singh, bankers. Nishikant Parida, manager. Anyone wants to add something else to this? Like, or you all guys think it's going to be the accountants or bankers who are going to be the domain expert in our case? Okay, so I guess you guys have the same answer. So yeah, like Harshad Mehta. Okay, so basically, the domain expert for our will be those marketing personals who like kind of analyze the data. Yeah, finance consultants. You can say kind of. तुम सभी का आंसर का combination you can say. So those marketing analysts are going to be the domain expert in our case. And yes, from doctor, I remembered Suhag. I guess can you give me 5 minutes so that like we will be coming to this. पार्ट ऑफ डीप लर्निंग पढ़ना तो चलता ही रहेगा, थ्योरी पोर्शंस भी चलता ही रहेगा, एंड विल सून बी मूविंग टू द कोडिंग पार्ट. बट बिफोर दैट, ये डॉक्टर से याद है, वी हैव सम लाइक some fun event for you. So should we move to that fun event? Are you guys ready? It's basically going to be some question answer question answer round type. Okay, cool. So moving let me share my screen first. Yeah, it's visible, I guess. So yeah, what you should do is you can go to www.menti.com and use this code. Let me copy paste it over here. Yeah, Lakshman, thank you. He has kind of, you can directly go to the link over here, or you can go to menti.com and use this code. And you will be seeing a question over there. You need to answer this. You have the like option to answer over there. Okay. So we have acha, 1-1 vote, Dr. Strange. So let's see who wins. Who do you want to win? Like, who do you want that it should be the guide? Like, इधर जिसका ज़्यादा vote होगा, that will be the universal guide for all of us. So let's see. You guys like knew like सबको पता चल गया इसे कैसे assess करना है. Okay, Doctor Strange is like having a more weightage. Tony Stark and Nick Fury are like दोनों same here. Okay, Doctor Strange again. Can Tony Stark win, or it's going to be Doctor Strange? We are going to consider Doctor Strange as our guide. It seems that it's going to be Doctor Strange. Tony Stark fans, where are you? Okay, Doctor Strange 17. Okay, cool. I don't. Okay, Tony. It seems that Doctor Strange is going to be our guide. Okay, fine. Okay. The more I wait, Doctor Strange is going to win by. Okay, so we'll be counting down to 5, and then जिसका भी ज़्यादा count होगा, that will be the guide for all of us. So 5, 4, 3, 2, 1. Yeah, Doctor Strange. Okay, which is your favorite magical spell from the Harry Potter movie franchise? Harry Potter, you guys must be the Harry Potter fans, right? Okay, wait a moment. Are you? I guess there is some issue with this. Give me a second, guys. Just a second. Um, yeah, there was some glitch was there. So yeah, I guess we need to start it again. We have already seen Tony Stark won, but yeah, sorry, we like you can the Tony Stark fans, you can now like you have a second chance to make it win. Okay, it's again Doctor Strange. Okay, Tony Stark fans, it's your go now. I think Doctor Strange fan अब क्या हो गया? Second time vote नहीं कर सकते? Okay, अरे क्या यार कुछ भी अभी थोड़ी देर पहले डॉक्टर स्ट्रेंज का फैन फॉलोइंग ज्यादा था अभी टोनी स्टार्क. Okay, I really feel bad for Nick, though. So it's going to be Tony Stark this time? Tony Stark? Okay, so lock kiya jaye, or we should wait for some minutes. Shloha, can you tell me what's going on in the chat section? I'm really curious to know about that. Like, I don't know whether what the guys are saying, whether I should wait more or we should be moving. So, guys, I should wait more, let Doctor Strange win, or Tony Stark, we should declare him as our guide.
Proceed further because Tony Stark is winning. It's the
This is your biased opinion, okay. Okay, I really feel bad for Nick though. He is just sitting over there at 2. Okay, fine. We'll go with Tony Stark. Okay, now that was like 13-13, 14-13. Okay, fine. Tony Stark this time. Okay, we can see DL is more preferable. Anyone who thinks ML is more preferable while finding sarcasm in memes? Okay, DL. Are you guys sure it's DL? Are you guys sure it's DL and not ML? Memes में sarcasm ढूंढने के लिए DL. Why? Okay, fine. So can anyone over there say me why you why you think DL is preferable, or why you think ML is preferable? Can you guys like answer in the chat section? Let me see the replies. Okay, so it seems that you are like kind of convinced that it's going to be DL, which is more preferable for finding the sarcasm. So basically, the correct answer is DL, deep learning. So anyone out there who can like tell me why it's deep learning and not machine learning? DL acts as human brain, so it should be more preferable. Anyone else who adds wants to add something to Durga's answer? You guys like selected DL, so there must be a reason. You must have thought something that it's going to be deep learning. And yeah, deep learning is the correct answer. It's a vast field. Okay, these are made for humans and nothing mimics. Yeah, that's true. Okay, basically, the earlier to identify and understand. Yeah, easier to. Yeah, you can see. So we have not got much into deep learning, but I'm very happy that you guys could guess this answer. The main reason is, yeah, my screen is set. Okay, the main reason is deep. जब हम this is not just हियर हमारे साथ इमेज भी है, इमेज के फॉर्म में भी डेटा जाता है एंड टेक्स्ट के फॉर्म में भी डेटा जाता है. सिंस ये मल्टी डेट हमारे डेटा मल्टी फॉर्म में है, सो डीप लर्निंग इज प्रिफर्ड देन मशीन लर्निंग. सो या द आंसर इज मशीन लर्निंग, सॉरी डीप लर्निंग. Sorry for that. Okay, so let's see what's the next question. Which movie comes to your mind when you come across the term AI? Okay, the timer starts now. You have 30 seconds. Sorry, 26, 25. Which movie comes to your mind when you come across the term AI? Guys, quick. You have to be quick. 18, 17. The countdown has started. Which 10 more seconds? 9, 8. AI सुनते ही तुम्हारे दिमाग में कौन से मूवी का नाम आता है? 3, 2, 1 and here we go. Time's up. Okay, we have अच्छा. Okay, that's just an biased answer. We didn't. Correct answer is Robot 2.0. Actually, we are just kidding. Iron Man is also Robot. Iron Man, Wally, Transformer. These all are correct answer, but this was just for like we just gave it like that. So yeah, that's it. So हमारा गेमिंग राउंड इधर खत्म होता है. So we will be again continuing with our studies. So let me just stop sharing my screen. Okay, fine. So Shuhag, we can like continue with the next part.
Okay. So, okay, so let's continue with the next part, right? So, if I talk about, we are still now we are talking about why deep learning or machine learning. We get two answers. One is feature selection, and another one is number of data increases, and also the accuracy gonna increase. Okay, so without wasting any time, let's move over to our main topic, deep learning. So we are going to learn a algorithm called neural network. Okay. It's just a concept. Means in machine learning we require same model, prediction, data set, bias weight, but same kind of thing we need in deep learning, but in a new approach or new algorithm. And the just it's just an algorithm, okay. And the topic name is deep learning. Okay. I want to tell you that the topic is deep learning and the concept we're gonna see is neural network. Okay. So if I ask you guys, if we let me show you a picture. If I shows a person picture, well, let pick any person. So if I show, if in real life you met this person in some day, or maybe today you meet this person. If you see this person tomorrow or day after some days, you can recognize, yeah, I met this person. But how we remember this person, or how we remember we know this person previously. So I want to say that. There is our brain never remember the bit by bit information about this place. Okay, our brain never remember the every bit information about this place. We just remember some kind of this ear, or this beard style of pattern, or lips style, or eyes pattern. Means I want to say that our brain never store the information. It only store the pattern, or we say experience, or the conclusion. Okay. So that means we never remember or try to remember any or all bit by bit information. We just remembering the pattern. Let's take another example. If let's say there is two twins brother, okay, and some one name is Tom and another one is Jack. Okay. And let's say we are, or myself, me myself Suhag, I met this person first time in my life. These two person first time in my life, and they are look alike of each other. That is, they are twins. And they introduce themselves to me. They say I am Tom and I am Jack. If I met this person after some days, or day after I met them, I can't recognize which one is Tom or which one is Jack, right? So I try to tell you that I met this person once in my life, these twins once in my life. I can't recognize which one is Tom or which one is Jack. But these persons have their family or their parents, okay, or their dearest or nearest one. They can easily recognize which one is Tom and which one is Jack. So why they are recognize which one is strong or which one Jack? Because these people are more acquainted with this kind of data. Means, I try to say in machine learning world, the model would more acquainted with the data, or it go more deeper to this data, or go more deep to this data set. It will get more and more accuracy and create the model more and more in correct way. So from this example, we get that our brain takes some time, or wants some deep data to correctly predict that thing, or create a model of function on that data set. Okay. Let's take another example. In our childhood, when we started to learning about the English alphabet, let's say in my childhood, I learned alphabet just like A in this shape. Then I practice, this is A, and I practice again and again, and I remember that this is A. But when we grew up and see in real world, there are many kind of this is A, this is A, this is A, this is, there are many kind of style of A. But we trained in this kind of A. But how we recognize that this is A, this is A, this is A? So here conclusion is, our brain only remember the facts or the pattern. It is never remembering the all information or bit by bit information. We just remember the pattern that this kind of structure is known as A. So this is also shown by this is also seem to be A. This is also seem to be A. This also seem to be A. So here our conclusion is our brain never store information. It only stores the pattern or conclusion. Okay, we gonna do the same kind of create the same kind of things in our deep learning part or in our neural network algorithm. Okay, so let's talk about our brain. If I take image of our brain neurons, let me search brain neurons. Yeah, I am taking this image. If I take a screenshot. Yeah, so here is the some kind of picture of our brain neurons. So this kind of let me take it. Yeah, this kind of small lightning kind of things. It is the main part of our brain. That means it's the main component of our brain which is responsible for our brain function. And this small kind of lightning thing, it typically known as neurons. These are typically known as neurons. Okay. And these neurons have also in your brain there are some part of neurons are responsible for something, and other part of neurons are responsible for another things, and some other part are responsible for another things. Let's say I also give you some example. Just like there are some group of neurons is known as motor neurons. Okay, those are known as motor neurons which are responsible for our walking purpose or moving our hand and legs. Okay, there are some neurons typically known as name is order neurons. Yeah, order neurons which is responsible for recognize the different kind of smells. Okay, so I am trying to say that there are neurons in our brain, this small part, and they also are internally connected with each other to predict the things more accurately, and they have their groups. Means some kind of neurons are for something, some kind of purpose, some neurons are for another kind of things. So we are gonna do the same kind of things our deep learning world. So if I take uh, the same kind of thing into neural network, let's say we are going to after some time in our coding part we are going to do this kind of thing. Let's say this is your brain. Okay, so let's say this is your empty brain, typical known as brain, or I am just naming it brain. Let's say this is your brain, means a clean brain, the fresh brain that don't know anything. Then in this brain we're gonna add some layers. Okay, some kind of layers or grouping kind of things. I saw there is some neurons are responsible for working purpose, some are responsible for our order purpose. So there are different kind of layers. Okay, and in this layer there are different kind of neurons. Okay, different kind of neurons. Okay. So here the image show you that this is brain. This small rectangular kind of things typically known as layers, and this circular kind of things typically known as neurons. So we are gonna do the same thing in our coding part. So before that I want to ask you how our brain get the data from real world. Means how we gonna input some data or data set to our brain. So there are 5 senses we have. One is eye, one is ear, one is nose, one is tongue, and another is feel. So I am naming it eye, ear, nose, tongue, or feel. So there are 5 kind of input organs or senses in your body part which give information to brain. Or typically these senses are connected with some internal neurons, and the neurons are gonna train in that kind of data set, and making the more and more perfect model. Okay, so uh, in a machine learning world same thing is gonna happen. These are our like our data set or any kind of that collection of data we have, and this collection of data gonna put it, we have to gonna put in our model, and train more and more and getting more accuracy with different kind of layers. Okay, so again, if I take another Excel sheet, wait, let me take a new Excel sheet. Okay, let's say when we collect some data from real world, I'm just converting it to a Excel sheet or data kind of thing. So let's say it's our ear column, this is our nose column, and this is our tongue column, this is our fill column, this is our fill column, and another one is our eye. Okay. And this is a prediction column. So if a person is see some kind of data like let's say a cup of coffee, cup of coffee. Okay. This is a cup of coffee, and if I show it, this is in real world or this image also, or let's say I show you some or I give you some cup of coffee. So how much data gonna put in my ear? So there is no input in ear to recognize this is a copy. So let's say from out of 10 my ear gets some kind of one information to recognize this is copy. How much are nose gonna mm, receive to recognize this is a cup of coffee? Okay, wait a second. Okay. There is a nose is going to a great work that we can smell and say we can smell or predict some kind of thing that this is coffee. The smell of coffee we can recognize and tell this is coffee. So nose is going to do a much work like I giving 7. Then tongue, yeah, tongue is doing a great work because we can taste this coffee and say that this is coffee. So here tongue I'm giving 9, and fill by toss this cup or by fill the hot or warm, we can somehow predict either it's a tea or coffee or a warm water, any kind of things, but we can somehow predict this is something like coffee. So I am going to give fill something like 6, and yeah, I also doing a major work here, so I also giving I data like 8. Okay, then I am randomly giving some data, I'm randomly hypothetically giving data. Okay, let's say this kind of data we received. Yeah, let me put some data like, and give this after getting this data, I am going to create a model. So let's say it's a brain and there are different it's a brain and there are different kind of layers, and in layers there are many neurons, and from our five senses we're gonna take the input and process in, and gonna give this data to our neurons or layers, and then process it. Okay, process it, process it and tell what is this, and give output what is this. Let's say I give this is, let's say the first one column is telling that this is coffee, but somehow after process the brain gonna tell this is actual answer is coffee. Okay, but the brain gonna predict that this is tea, means it's wrong. Okay, so our brain predicted wrong. By comparing this output, we know that this is actually coffee, but our brain predicted this is tea. So we do some wrong process, or at the time of creating the model we do some wrong kind of things that it's predicting wrong. So we are getting back to this process or this data set or first layer, and again do some process and again going to predict. Let's say this time also it is tell it's warm water. again our brain do predict wrong things, so again we are going to back and again process something and again predict. So and finally let's say it's predicted, it's copy, great. But here I am trying to say, I am trying to tell you that as soon as much as our brain gonna see that we are predicting wrong things, so till it don't till does not get the right answer, it keep going back, keep going back, keep going back, and process the things and giving us output. This keep back kind of things is in machine learning world typically known as back propagation. Just remember these terminologies we are gonna use in our coding part. Back propagation means we should go back and back till we don't get any right answers or predicted right. So we going back is typically known as back propagation. In the same way, if the information is going great and we predict the things rightly, or we predict the things in a right manner, so we should give the output of this layer to this layer. Then I give output of this layer to this layer. So here the data is predicting in great manner. So I am forwarding the data to the next layer, next forwarding the data to the next layer and predicted the things. The forwarding the data to next layer kind of things is typically known as feed forwarding. Okay, just we are forwarding the data because it is working great. So here we learn two kind of terminologies. First one is back propagation, which help us to do our model or judge our model to do more and more perfect. And feed forwarding is happen when we give the data accurately. Okay, so okay, I take another example. Same kind of thing, it's brain and it's layer. So our neurons, I told you there are some neurons for working purpose, there are some neurons for other purpose. So what I mean, I want to tell you that these neurons are typically associated with some function. Means in our brain part we see in a in a brain part we see there are some neurons for some kind of purpose. So we before fitting the model or at the time of getting the model, we should tell these neurons what kind of function we're gonna use. Means what kind of function should you use to get more and more perfect model. So at the time of creating the model we have to declare that function, and to declaring that function is typically known as activation function. We should activate these neurons with some function. So at the time of creating this model we should give some function to these neurons, and after that when we feed the data the neurons gonna work like that function and give us more and more accuracy kind of things. Okay, and there are some two to three kind of terminologies, and then we are going to move over to our coding part. Okay, there is another kind of term. Let's say this is our data set. Okay, and we are going in data we have some number of columns, and this column gonna give information to our neurons, and then we have our activation function which are helping us to creating the model. But before that I told you function means what. Function means they are associated with some bias or weight. Means we have to tell our model there is some bias or weight. Maybe let's say there is a model which accurate weight is 10. Before creating the model we can't predict what is the weight. Let's say a hypothetical example, we know the actual weight is 10. Okay, but we have to tell the neurons that where should you start. Means where we should start that means we should tell the neurons that what is your starting point. Means where you should start this weight. Let's say I say you should start from 1. Means I told these neurons that your starting weight is value is this, but you have to find the accurate value by doing some functions or kind of things. So these kind of things in machine learning world typically known as kernel initializer, kernel initializer or weight initializer. Weight, the another synonym of weight is kernel. Means we have to initialize the weight value with some kind of function or some kind of number. So in this data, when we feeding this data to our neurons, they are associated with some weight and bias. Here is also it is associated with weight and bias. Here it is also weight and bias. So every input is associated with some weight and bias. Okay, and we have to initialize this weight and bias. The weight initializer is typically known as kernel initializer, and the bias initializer is typically known as bias initializer. That means uh, we have to initialize this this parameters with some value. Okay, so again, let's say my actual weight is same kind of example. My actual weight is 10, but but I initialize the value from 1. Okay, but then my model get predict just like 2. I take the example hours and marks 220, 330, 440. Our model gonna tell it is it is getting perfect or not. So there is a function or mathematical function is y equal to mx or wx. Okay, so here x is in first data set, there x is 2, y is 20. So it is store 20 in y and store 2 in x. Then it uh, keep hit and try. What is the value of w should satisfy here? Maybe it's initialized with let's say 0. Let's w is initialized with value 0, and then it calculate something and find that 0 into 2 equal to 0, and save this 0 in a variable called y hat. Okay, so our actual value is 20, our predicted value is 0. So how we should know our model is performing well or not? It never compare themselves with each other. Okay, it never compare themselves with each other. It's only see the difference between these two parameters. Means it is subtract y with y dash, that is 20 minus 0, it is 20, and say no, we are wrong because we have a 20 steps away, or we are in a long distance from our actual value. Then it's increases w, let's say it increase to 1. Again do some calculation here, put 1 and getting 2, it is stored in y hat, and again it is subtracting to 20 minus 2, it's 18. Means our first we have 20, then now it's 18. Means our difference is getting decreases, means we are on the right path. So someone here to judging us it's going on a right path or not. Means the this subtraction is typically known as loss. Means how much loss we have. Means our actual value is 20, but now we have 2, so how much loss we have? Means 18. So we should try to decrease our loss. The loss, more and more the loss decrease, the more and more the accuracy gonna increase. So here also we are initialize this weight with some value, let's say 1, and it is gonna hit and trial and check which value is gonna affect perfectly for the model. But how this one gonna reach 10? Let's say in same kind of thing, w gonna 1, and I will check in the function and check how far we are. So this is gonna affect the model, we are in the right path or not. So this one gonna it's not working correctly because our actual value is 10, but it's now 1. Then it try with a some value, let's call 1.0001. Okay, so this value gonna try again, see there is a wrong answer. So then increase our weight value to 1.0002. Again it will give wrong prediction, and it give answer wrong, and again it's increasing. But I am trying to say that we are increasing in a um, we increasing the weight value in a very slow manner. Means to reach 10 we may need 2 or 3 years to reach from 1 to 10. But we should tell our model how much step we're gonna take. Means we should take big step to find our weight. Wait a minute, guys.
Okay, so guys, can you tell me what are the terminologies Suhad just discussed now? Like one was the activation function, then backpropagation. वैसे ही और कौन से terminologies तुम्हें पता चला अभी? Okay, we have kernel initializer, yeah. Forward feeding, yeah, perfect. Backpropagation, yes, backpropagation. Backpropagation, yeah. So Dusra, he just told us about that loss function thing and this bias initializer. You will be seeing that all these terms, what he is trying to explain, he is trying to give you the theoretical intuition. And when the code comes, these terminologies are going to play really a very important role. So if you're clear with the theory part, you won't be facing any issues with that. So yeah, just keep paying attention.
Okay, so yeah, my screen is visible, right?
Yeah, yeah, sir.
So here my initial value is 1, and we have to find the value, or we have to set the value 10. But I should tell our model how much steps gonna take. It should be big steps, or we can take small steps to find out weight. It's all upon us how much step we're gonna take. It may be override the value, it may be raise the value, anything can be happen. But we have to tell our model how much step are gonna take, and this step kind of things is typically known as optimizer. Okay, optimizer. Or in optimizer, there is a parameter mainly affected is known as learning rate. Learning rate means how fast I am gonna learn this kind of thing. Means how fast I am gonna increase the parameter or kernel or weight and find my actual weight. Okay. This is known as optimizer, and I'm just explaining the last terminology. Let's say we are now in Bhubaneswar, and this is we want to go Delhi. Okay, this is Bhubaneswar and Delhi. Let's say the distance is 1,000 kilometer. But how the navigation kind of things or Google Map know that we are in a right direction? Let's say we go in this direction. Now we are in at this point. So what the technology do, it is just calculating the distance. Means how far you are. If the distance is increasing from the actual value, let's say here it's gonna 1100 kilometer apart, and our actual distance is 1,000 kilometer. Means here the distance gonna increase. That means we are in a wrong path, that we should decrease our distance. So again I change the direction. Let's say I go in this direction. Now in at this point my distance is 990 kilometer, and our technology gonna calculate this and see, yes, we are in the right path, because initially I have 1,000 kilometer, now it's 990 kilometer. Means I am in the right path. So so in machine learning or in deep learning model, there is someone to guide we are in the right path or in the wrong path, and path this function is known as loss. I also try to explain you here. That is what is loss. Loss is just guiding us we are in the same path or not. We are in the right path or not. Okay. This kind of theory is enough for our coding part. So now let's head over to our coding part. Okay.
Before starting the coding part, if you have any doubts regarding on all this concept, then you can ask him.
Do you guys have any doubt regarding to what all the concepts you have explained? Because it's very important that you understand all this so that we can move to the coding part.
Suhag, someone asked that can it be one step?
Uh, I told you we can predict which weight gonna be great for our model. I just take here a hypothetical example that our weight may be 10. Okay, but before creating our model, we can't predict which weight gonna great for our model. So how we tell that in one step we're gonna reach to the accurate weight? Yeah. So we have to take small step or some average step. Then we can set the learning rate or parameter some kind of that we can get the accurate weight. And this is also in machine learning world typical known as adaptive learning. The term is called adaptive learning. This is also a concept behind the deep learning, but it is itself a topic. It may take uh, more than enough time. So that's it.
Someone asked that how we decide which function goes into the kernel initialize.
Yeah, I am going to explain you in the coding part. So anything else?
I think there's no any doubt. You can proceed.
Okay. Okay, let's get started with the next part, our coding part. So yesterday, guys, we are using. Where is my? Yeah. Uh, Sorry. Yeah. So yesterday we are using our Google Collab. Okay. So yesterday we were using Google Colab, and today I am going to use the Jupyter. First difference between two things that Google Colab is a uh, let me open a new tab. So Google Colab is a IDE, means it's help us to improvise our coding or giving some hint, but it's a Google product, means if we run, there is a Google. I'm talking about there is a Google Colab and I have Jupyter. Okay. So when we run a code in Google Colab kind of IDE, it is gonna run in the instances that present in Google data center. Means Google have their own data centers, they have their own CPU, RAM kind of things, and they are gonna use their instances to run this code. But I am using Jupyter Notebook, which gonna help or which is run in my local RAM or in my this computer RAM and gonna use its RAM and CPU itself. So if guys are comfortable in Google Colab, you can use Google product, or anyone is comfortable with Jupyter Notebook, they have enough space or enough RAM in their system, they can use Jupyter Notebook. But here I am showing you some kind of libraries or kind of things which gonna we have to manually install and know which library gonna help us in creating the deep learning model. But in Google Colab they are pre-installed, so I am using Jupyter Notebook to show which library gonna we are gonna using. Okay, so here I'm using uh, Jupyter. Let's start with a new file.
Guys, adding on to this, yesterday we practiced using Google Colab, so I'm sure some of, like most of you might be acquainted with it, and some of you must not be aware about Jupyter Notebook, but you don't need to worry. The notebook link I have sent it to you. It has like The deep learning codes are over there also. What Suhag is going to live code those things only. Like if you Suhag, for a second, can you stop sharing the screen so that I can just show them? Yeah.
Okay.
So yeah, let me show you. My screen is visible, guys. I guess it's visible. Yeah. So this was the day one steps that we carried out yesterday, and this is Google Collab, by the way, if like anyone was not present at that time. So and this is the day two stuff. So we have kind of implemented and understood the code till here. We got 0.73 accuracy, and this is the day two code. So Suhag is going to like live code this all of this in Jupyter Notebook, and he is going to explain you like the intuition and why we write this code and how those terminologies that he discussed now are going to be utilized over here. So what I basically want to convey to you guys is that you can go for Google Colab, and if you already know how to work with Jupyter Notebook, you can go for that. No issues with that. But if you want to, if you are kind of new and you want to kind of simultaneously run, so you can just implement this codes. This codes I have just like you can run the cells the way we did for day one. And basically we are trying to show you that गूगल कोलैब के केस में क्या होता है कि इधर जो पैकेजेस होता है वो प्री इंस्टॉल्ड होता है. तो what we want to share to you is that when you will be using Jupyter Notebook or any other installed software, you need to like install the libraries over there. It doesn't comes in handy like इसमें already वो software वो libraries installed होते हैं. But Jupyter Notebook के केस में हमको उसे खुद कमेंट्स देके इंस्टॉल करना पड़ेगा. सो जस्ट टू गिव यू दैट इंट्यूशन, वी आर यूजिंग फॉर टुडे we'll be shifting to Jupyter Notebook, but you guys so as to run your code you can just run the cells. He is just going to write the same codes. He is going to live code them and is gonna explain you. So yeah, that's it. Shuhag, you can take over now.
So till now we understand on machine learning. In machine learning there are two approaches, traditional and newer approach. In yesterday session in traditional approach, we are using a library called Scala. Okay, means it's a library which has its pre-created functions and variables and many class object kind of things, and we are gonna use it for traditional. We are going to use a library called Keras. Okay, so Keras is a library which is gonna help us to create a model on deep learning or neural network kind of model. So, another thing, sklearn is built on top of NumPy. Okay, NumPy is another library which is and sklearn is built on top of this NumPy. Similarly, we have a library called TensorFlow. So TensorFlow is a library, and to use TensorFlow library functions or any kind of things, Keras is a new library or API kind of things which is built on top of TensorFlow. Means Keras is built on top of TensorFlow, but internally we are using TensorFlow. But Keras is just like a API kind of thing. If I talk about TensorFlow, we in NumPy array or in any kind of array, we know there are many kind of array like 1D array, 2D array, or ND array, any kind of array. So if we talk about array, this is a 2x2 matrix or array kind of thing, and we are saving. This is a 2D array kind of things. Okay. Similarly, TensorFlow is also a kind of array kind of data type. If I search on Google, if I search on Google Tensor, and it's the official document of TensorFlow. What I gonna get that TensorFlow is just like a multi-dimensional array. Okay, TensorFlow is just like a array or multi-dimensional array, and it is also similar to NumPy kind of array. Okay, just think TensorFlow is a data type just like array, or we are gonna use it. And if I again search what is TensorFlow, which is our main topic, TensorFlow. So here is a documentation on Wikipedia, or you can prepare any documentation. So Tensor is a free and open source software or library in machine learning for machine learning in artificial intelligence. It can be used across range tasks and particular focus in training and inference deep neural network. And the main thing is TensorFlow is developed by Google itself. Okay, and the why we use TensorFlow, that it also write in the documentation that TensorFlow is environmental independent. Means we are developer, we write a code in some language and it works in our system in great. But when we transfer this to testing testing group, or we are gonna deploying this code in some kind of hosting kind of things, it's work great in our system, maybe it gonna fail in another system on or another environment. Means they only depend upon the environment or the system requirements. But TensorFlow is so flexible that it is gonna run in any kind of operating system or any kind of environment. It can be run in Linux, macOS, Windows, mobile, or mobile in Android or iOS. So main purpose of using TensorFlow is its environment independent. Okay, so so I told you for deep learning we are using Keras library. Okay, so in Google Colab we have Keras library free installed, but I am gonna install in my system manually. So for machine learning, you are using Python. So in Python there is a command called pip. Pip is a Python package management kind of command. And for pip, we can tell pip please install a library for us, and this library is Keras. Okay, so we have to install Keras. I have already installed, so it's showing that it's already satisfied. You have to, if you are using Jupyter or any kind of IDE, you have to manually install it. So yeah, it's installing. Let me some time to install. It's finishing. Okay, it's doing its work. Yeah. So let it be run, and I am writing here some code. So I'm going to from Keras. Keras is a library. Okay, and it's had a module called models. From Keras.models, we are going to import a function or a class called sequential. So what sequential gonna do? It's taking time. Yeah, it's finished. So from Keras library, there is a module called models or Keras.models. We are inputting a function called sequential. So what sequential do? I am gonna explain you what is the benefit of sequential. Just what sequential do? It only create a empty brain kind of things. Means only these rectangulars and empty brain. Means let's say it's a empty brain. Okay, so sequential function gonna help us to create this empty brain. Okay, so if I run it, it is throw an error. What is the error? So it's showing there's no module named TensorFlow. So here I am want or try to show you that Keras is a library, but it is required TensorFlow library pre-install for to use Keras. You require TensorFlow. So we have to also install TensorFlow. So pip install TensorFlow. You have to if you are using any local ID or Jupyter kind of things, you have to manually install it. So here we can get that you have to use Keras, and for Keras we require TensorFlow. Okay. Okay. After installing the TensorFlow, let me get it to install successfully. Yeah, it is successfully installed. If I again run this code, it is gonna run. It's running. Wait some time, and now it's run successfully. So I am going to call this function sequential. Okay, what sequential do? I told you it's only creating a empty brain kind of things. Okay, so if I and this I am gonna create a class object kind of thing. So I am going to save this sequential function or creating a object of sequential class and its name model. So now what I am doing, just creating a empty brain and naming it model. Okay, so my brain is my empty brain, its name is model. So now model is created. There is another function from Keras that layers. There is a function called dense. Okay, what this dense do? After creating the empty brain, we have to add some layers. I told you there are some number of layers which have number of neurons to train our model. So we have to add some number of layers to our empty brain. So dense gonna help us to add some layers to this empty brain. So I am importing dense. Then I am my empty brain. I have my empty brain model. Here is a function called add. This add gonna help us to add something to my empty brain. I'm gonna add here the dense function, which is gonna add some layers. And in this now dense can add some layers to my empty brain. So if I click on shift plus tab button, okay, I am clicking shift plus tab button, and it is gonna help us a documentation kind of thing, gonna open a documentation kind of things or helping hand to coding in coding part. So in dense function there are some arguments. Okay, we have to declare this or initializing. We have to require to initialize these arguments. So there is a first argument called units. Okay, so what units gonna do? Here units gonna add the number of neurons to our layer. First we declare the empty brain, then we add the layers, then we are gonna add some neurons to it. Okay, so we are the number of neurons we need, we have to add. Okay, so here units is a parameter or argument in dense function which is gonna tell how many units gonna add. So here let's say I am adding 5 units of neurons. Then another. Then second parameter is activation function. Before that, I want to tell you that there is another parameter called input shape. Okay, so input shape is a parameter. First, which input shape means. Let declare me first input shape. So what this input shape gonna store? There is a data set, and the data set have a number of columns. Okay, these are columns. So this first layer is taking input of my data set, means this first layer only interact with my data set. So as this first layer is taking input from my data set, this layer is typically known as input layer. Okay, and the final layer which gonna give us output is typically known as output layer. And this in other layers are all layers is typically known as hidden layer. Okay, so in my input layer, I have to store my first layer. I have to declare here how many columns gonna come. Get it? So how many columns or how many features gonna come to my model. After that, I have to proceed further. So let's say in my data set I have 6 columns or 6 features. So I have to declare here input set is equal to 6. Then taking the help of documentation. Then another function, another parameter called activation. Okay, so what is activation? At theory part or before some time I already explained you what is activation function. We have to declare some function to our neurons to act like this. So we have to choose or give our neurons some activation function. So I am just giving some activation function. I am taking help of Google Keras activation functions. So there, this is Keras official documentation, and here it declare all kind of activation functions. Okay, so you can use as a requirement comes. We can use this kind of activation function. There are many kind of activation function. Okay, activation function means what? It's just a mathematical function. So we have to use. So I am going to use a function called ReLU. Okay, so if we take a look on ReLU function. Yeah, if I take look on ReLU function, so what's ReLU function do? Before, if the input is negative, okay, so it's gonna give nothing. Means it to give no output to us. But in positive kind of things, it is gonna give some output. And in negative, I try to say it's in negative. It is gonna it don't give us any value. Then that means because I am using ReLU because in my data set there is no negative value. Means in real world there is no input like negative. We have to always give some positive value. So here I am using the activation function called ReLU. Okay. Next, I also told you some initial. We have to initialize the weight or bias. So here is also a parameter known as corner initializer. Sorry, this parameter corner initializer means initializer for the kernel or weight. We have to initialize the weight value. So here we are using kernel initializer. And if I take again the help of documentation Keras kernel initializer. So here also they have a document on all type of initializer. So I am gonna use a initializer called zeros. There are many kind of initializer, but I am gonna use a initializer called zeros. So here I am using zeros. And same we have to declare like a bias initializer. First we have declared kernel initializer. Now we have to declare bias initializer. I am using the same function. Zeros. Okay. So before running this, I'm declaring just this kind of parameters. So before running this code, I want to show you something else. Yeah. So I created my sequential. I call my sequential function which created empty brain, and in model dot there is a function called getConfig. Okay, this function gives us some about section kind of things about our model. So if I run it, it shows that you have a brain, empty brain. Its name is sequential, and it has no layers. I told you what sequential do only it's create a empty brain. So sequential just create a brain with no layers. So here is no layers. After I run this, if I run this, oh yeah, it's a through an error. Yeah, it's saying that int object not retrievable. What is this? If I take a look on documentation, there is a parameter I told you it's input set. We have to tell our neurons how many inputs gonna come. So here it has been told that input set should be in 2D format. Okay, we have to give the input set in 2D format, but I declare here integer. So it through an error. And in programming world, to convert this integer to array, we have this kind of format. So now it's a array format of 6. So as soon as I click enter, it's gonna run successfully. Okay, that means a layer gonna is added to my empty brain. If I check model dot get config, okay, so first when I run this command, it is showing there is no layer. Okay, after adding this layer, if I check, it is showing all information about this model, that your model name is sequential, you have 6 neurons kind of thing, and no, you have, sorry, what, yeah, you have 6 input cell and you have 5 neurons. Okay, I declare already here it is 5 neurons, and your activation function gonna use is relu, and some kind of kernel initializer and bias initializer I have declared. So what I do here, I just added the first layer to my brain. After that I am going to add some another layer. They are the same function. I'm just copying this code and paste it here. So in first layer, we have to declare the input shape, or yeah, first layer we have to declare input shape. But in second layer, we don't require to declare input shape, because this is one kind of model and this is another data set. So this first layer don't know how many input gonna come from outer data set, but this layer know but how many number of output gonna come from this layer. So they are internally connected with each other, and they know the output of this layer is the input of this layer. So we don't require to declare input shape in second layer. So here I am not using input shape, and yeah, I am using the same kind of activation function. And if I initialize the kernel initializer or bash initializer zeros, it's gonna work. If I don't declare it, it's gonna use their by default function. So if I don't use any kind of kernel initializer or bash initializer, maybe it in documentation, but you can just check in Google. If I don't initialize it, kernel initializer is going to use a function called glorate function. Maybe it declared here. No, it's not declared. You can check the documentation. If I don't initialize the kernel initializer with value, it's gonna take a by default function kind of things. It's known as glorate function, and the bias initializer is going to use some uh, by default kind of function known as zeros, which is we also use here. Okay, if I don't declare this kind of things, they are gonna use by default. So here I'm adding another layer. Okay, just like get config, there is another function model dot summary. Okay, okay, it gives us some overall idea that your brain has one layer, two layer. In first layer there are 5 neurons. Second layer I also added 5 neurons. So here is also 5 neurons. What is this parameter kind of things? So I am just explaining you. Uh, let's draw a new picture. Okay. So it's layer. Here is neurons. Yeah, here is the, let's say we have we input shape is here. We take input shape. Yeah, let's say we take the same example. We have 6 input shape. Okay, so let's say we have 6 input columns here. 1, 2, 3, 4, 5, 6. Okay, and in first layer we have five neurons. Okay, so I'm going to add 5 neurons to a file layer. This is 1, 2, 3, 4. Let's say 5. Okay, this is not okay. Let's say we have 5 neurons in first layer, and we have 6 columns. So this input gonna interact with these neurons. This is also gonna interact with this neuron. This is gonna interact with this neuron. This is gonna interact with this neuron, and this is gonna interact with this neurons, and also this is gonna interact with this. So there are 6 number of inputs which is gonna interact with one neuron, and every input have associated with some bias and weight, 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 and bias and weight. So there are six one, two, three, four, five, six. So number of inputs is equal to number of associated weight. Okay, so there are six number of weights. So these neurons is associated with six weights, and also six constant kind of things are bias. Okay, we also know if there is n number of constant k1 plus k2 plus k3 up to n number of constant, it is gonna add it together, the constant gonna add it together and convert into a overall constant called k. Means 2 plus 3 plus 4 can be written as 9. Okay, so constant gonna add and making a big constant or are added together to be a whole constant. So these six bias gonna added together and giving us a one constant output. So here one neuron is associated with six weights and one bias, that is seven parameters. Okay, so one neuron is associated with seven parameters. Similarly, there are total five number of neurons. So they are associated with 7 into 5, that is 35 parameter. So here the parameter is 35. Okay, get it? So I added two layers. Then my plan is here to add just adding two layers, and I'm just adding the final layer. So I'm just copying the same code. Okay, and pasting this here. Also in final layer, we don't require any input shape. Also for I am not declaring any bias in initializer or kernel initializer, but we have to in output layer or in the final layer we have to choose units and activation functions correctly. uh, just showing something in machine learning problem, we mainly have two kind of problems. One is regression, other one is classification. Okay. In regression, we have an output from minus infinity to infinity, means any kind of number. Means it may be 100, it may be 1 billion, any kind of number. But in classification, it's further divided into two parts. It's binary classification and multi-classification. In binary classification, it has two output, means 0 or 1, pass or fail, existed or not existed, means there is only two kind of output. So and in multi classification there are multi outputs. Okay, so we have to choose our functions carefully, which as our requirement come, means as our output come up, we are choose our function for our in that requirements. So in regression we are using a function called linear. Okay. In binary classification, we are using a function called sigmoid. These are the functions just like ReLU, but these are typical sigmoid function is for binary classification, linear function is for regression, and for multi-classification, there is a function called softmax. Okay, so we have to choose how many which function we're gonna use in the final layer according to this concept, and we also have to choose how many output gonna come in the final layer. Let's say this is our final layer. Okay, so if the output is regression kind of thing, so there is one neuron is enough to give us output. Okay, so one neuron is enough to remember the bias and weight and give us any linear value. A regression kind of, that is minus infinity to infinity. So it one neuron in the regression model, there is one neuron enough to give us output. Also in binary classification, the one neuron is enough to give us zero or one output, or pass or fail output. Means one neuron is sufficient for linear and binary classification. For multi classification, let's say we have five classes. Let's say we are going to job in a company. There are many domains just like cloud, data science, maybe developer, or any deployment team, and many kind of jobs they are available, and these are typically known as classes. Means this is a class, this is a class, this is a class, this is a class. So we have to choose which class is we have, so the model should predict which class is perfect for this person. Similarly, for multi-class, we have to choose the number of neurons equal to the number of classes. Okay, let's say I show my computer a photograph. Okay, and ask my computer what is this photograph. So my this, let's say this neurons is for giraffe, this is for elephant, this is for lion, and this is for tiger. My model predict that this neuron is typically for giraffe, and it predict that it's look like it's 60% giraffe. This neurons is typically for elephant. This is predict that somehow I think this is 10% elephant. This predict, let's say this is showing that this is 20% lion, and it's showing that it's 10% tiger. So here more accuracy is going to be to this neuron. So this neuron after then the final layer can predict that this is more look like giraffe. Okay, because this neuron is predicting more for this for matching the image. So I am going to tell you that for regression there is one neuron is sufficient. For binary classification one neuron is sufficient. For multi-classification we have to use the number of neurons is equal to the number of classes. So in our Churn modeling dataset there is a binary classification kind of thing. So here I am gonna use one unit of neurons. Okay, then okay, finally I am checking the summary. So here there are three kind of layers we added. First one is 5, second one is 5, or the third one is our final layer is typically 1 neurons. In machine learning, after creating the model, we directly feed the data in the model. But in deep learning, before fitting the model, we have to do some compile kind of things. Means I show you the loss functions, the optimizers, that in the theory part. So we have to declare that parameters here. Means if I check model.compile function, if I check the documentation, there are many kind of parameters, just like optimizer, loss function. We already discussed about this. So I am going to declare optimizer. So if I also take the which optimizer I am gonna use, if I choose Keras optimizer and go to the documentation, here many kind of optimizer are available. I am going to use a optimizer called Adam. Okay, this is very famous. You can give this documentation a read and understand the optimizer. So I am here going to use the optimizer called Adam. Okay, and it should be in the string format. Next we have a parameter called loss. Okay, so I am going to use loss here. Loss, I am also checking the documentation. Keras loss functions. Okay, so here there is two kind of problems I told you. There is one is probability or classification kind of problem, another one is the regression problem. So for regression problem we have different kind of loss function. We can use any of them. For probability there is one is binary classification, another one is multi-classification. For binary classification kind of thing we have a function called binary cross entropy. For multi-classification we have a loss function called categorical cross entropy. So I have binary kind of dataset, so I am going to use binary cross entropy and copying this function and pasting here. Okay, so I declare my optimizer, I declare my loss function. Now another yesterday we see to see so our model is trained good or not, we have to check a accuracy, and accuracy is determined by a matrix kind of thing. So here also to check accuracy I am declaring matrix, and the matrix is gonna give my accuracy. Okay, so this is our model compiled. After this we have to feed the data in my model. So this is the overall idea of how neural we have to code, or how deep learning gonna add the neurals, or how create an empty brain, then add layers, then add neurons to it, then choose activation function and kernel initializer, bias initializer, and this kind of things. So now let's take our data set and finally create our model. So till now you have any, if you have any doubt you can ask. Otherwise, we are going to take the data set and train our model. Okay. So, no one. Okay, let's take the data set and finally create our model. Or I have the pre. I also have my uh, pre-created model. So I'm just showing you this. So I have.
Before
Hmm.
before jumping into that step, so ask some if they have any doubts so far.
Consul.
Please ask if they have some doubts regarding all these terms and technologies.
Yeah.
Uh,
I
hey guys,
guess they are not having any doubts. Maybe we can move to the code section. Like we can, they just saw like how the model is built using TensorFlow and all. So maybe can you see the layer parts code, layers part code again? That addition of layer. Shohag, are you there? We have a
Yeah.
doubt. We need to, you need to show that the addition of layer part again. Like you can show him the code. He
Yeah.
just coded right now.
Okay. So which part adding the layer, right? Yeah. So first I have created this, I call the sequential function which created the empty brain kind of things. Then in that empty brain, I'm gonna add some layer. Here is the dense function which is gonna help me the add layer. So dense function is just helping me the add layer. Then in dense function I have some arguments to declare, means how many neurons I need, what is my number of columns in my data set, which activation function I'm going to use. So in this way, I can add layers to my model. So that's it. Any other query?
if you have any other doubts, then ask it right now. And after that, we'll jumping into the churn modeling part. How can we build actual deep learning model on churn modeling? And there we're gonna see the how the accuracy will increase in deep learning part, right? So guys, if you have any doubt, then ask, or otherwise we can proceed. Someone has doubts like a module not found error, no module named Keras. Uh, you have to install it using like he show you pip install Keras. There may be some difficulties in installing the module. I think you haven't installed it. You can check by a command like pip list in your CMD and check
Yeah,
if
I'm just showing you. To check, just I'm clearing my screen. To check whether the package is available in your system or not, you have a command called pip list, and after entering, click enter. It is so all the libraries available in your system. Okay, so I have a library here. It's showing I have Keras library in my system. Also it's showing I have TensorFlow here. Yeah, here it's TensorFlow library also here. So it's so all kind of library or all library are available in your system. So command is pip list. Okay, this pip list.
uh, okay, so I think they don't have any doubt. You can proceed with the final model.
So, guys, should I do the churn modeling, creating churn data set creating model in live code, or should I show you only the code, means pre-created code, or should I go with live code? What do you prefer?
Uh,
Live code, okay. No, I'm just asking if you have any time issue. So let's get started with live code. Okay. So, yeah, we yesterday see a data set called John modeling. I also, you also guys have question what is comma separator file, right? So if I took look, take a look on this data set from this, so it's showing that these data are just separated by comma. Do you guys, it's visible, right, Lakshman?
Yeah, yeah.
Visible.
Yeah, it's visible.
Yeah, right. So this file is just separated by comma. Do you get it? So that's why this file is known as comma separator file. And when we are open this file in Excel sheet or yeah, Excel sheet, so it's showing in tabular format, right? But the actual format is in comma, just like image. Our image just like a array. If you are study about computer vision or any kind of things, so image is just a array. The dot jpg you are using in image, that is dot jpg or dot jpg, it's only converting that array to a rgb format or red green blue kind of format to show us a real photograph. So the actual format of our dataset is comma separator file. Okay, and when we open this file with this kind of software like Excel sheet or spreadsheet, so it's showing it in a tabular format. That's it. So let's start with our coding part. Just closing it. Okay, where is my code? Yeah, here. So in data science or in Python, in our pre-created library, there is a library called Pandas. I'm just putting this library. Okay, in Pandas, there is a function called read CSV. This function helps us to read the CSV file for our local storage or any kind of storage. So in Pandas, there is a function called read.csv. It's gonna by this function I can read my this comma separator file. So I'm just its name is John modeling. So I'm just declaring this name here, John modeling. Yeah. So by this code I can load my comma separator file to my coding part or in pandas format. Okay. As soon as I click enter, it's load to my data set. Means the comma separator file is gonna read in the format of tabular format, like in a pandas library. So here is the dataset loaded. So I am is going to save in a variable. Okay, I'm going to save in a variable called dataset. Sorry, dataset. Okay, so this tabular format or pandas format is gonna save in a variable called dataset. So yes, if I also show you data set, same data. Okay. Um, so I told you in machine learning we have to choose manually which column we require or which is not to be. But in deep learning, it's gonna choose automatically. But there are some kind of rule also. Let's. I'm just pasting here. Let me some time. Yeah. So if I see here, I have another. Sorry, wait a minute. Yeah. Yeah. So in this data set, I have many number of columns. Okay. And also I have a variable or prediction kind of things is in my last row or in my last column is known as exited. So we have to predict if it is exited or not. But from this dataset or from previous understanding, we can tell that row number is just a continuous kind of number. So this not gonna affect my exited, my customer is exited or not, right? Similarly, customer ID also unique. This is not gonna affect my output. Surname is also a name kind of thing and is unique or repeated, but in not affecting my exited. Yeah, credit score is affecting geographic, affecting gender, also affecting age, other things are affecting my output. But these three column is not gonna affect my output. So I, if I give this model, this dataset to deep learning, it's credited that means it's omit this what columns, but it require and it consumes some CPU or RAM can means it consumes some CPU power and RAM power, means it's cost effective. Get it? So to choose deep learning, this column gonna take or this not here, the deep learning gonna do some functions or works, and finally it get that this is required, this is not required, this is required, or this is not required. Okay. So why we give our computer to do some CPU work or RAM? By looking at this data set, we can predict that this column is gonna not affect this, not affect this. So to save cost and CPU kind of thing, because in computer science world we have a topic called DSA, where we have to save the mainly purpose is to CPU, save our CPU time and our CPU cost and time. So I am gonna add to my y my prediction kind of variable. So I have to predict dataset. In dataset there is a column called exited. Okay, this column is only our the value is the customer is exiting or not. So I am just means I am just separating the column from our actual data set, so and saving in a variable called y. Okay, so y is containing all the exited column data. Then I have to declare a x. I am going to declare a x variable which is gonna taking our input, means our column and feature kind of thing. So I also there is yeah. Wait a second. Before this, and to show you data set, there is a function called columns, which is gonna show all the columns name in this string format. So if so I am going to store in x variable data set, and which column I am going to add, I am going to add it manually. Means I should told you row number is not gonna affect, so I am not adding to it my data set, final data set. Then customer id is also not gonna affect, surname is not gonna affect. After that I think all other things gonna affect without exited, because exited is our output or prediction kind of thing. So I am just copying all these names and pasting here. Okay. So if I see now x, yeah. So x is from dataset. I cleared these three rows, and now I am going to show you that x is contain this kind of uh, data in my variable. So again, another thing. Let me take another tab. So here is also, so here we are seeing that before creating a model, I have to I have to say you something that computer always understand the numbers. Okay, means computer is always comfortable only with numbers. It is never gonna understand any string, any kind of data. It's only understand number and in the form of 0 and 1. You you get it? So I am trying to say that computer only understand number. In this in this data set, these column are in normal format, right? But before giving to a model, we I have two columns, that is geographic and gender. These are in string format. So computer give a model never train on string, because it's throw an error that this is string kind of thing. I don't understand things. I only understand the numbers. So you have to change this string kind of thing to numeric form, or some kind of you have to provide me this kind of data in some numbers. Okay. So so to convert these kind of things into number, yesterday we are talking about a concept called label encoding. What label encoding do is just converting the categories to a numbers. After converting numbers, we have a function called one hot encoding, which converting the numbers to a 0 1 format. After this 0 1 format, we just eliminating one row or column. We have 2 to 3 steps. One is label encoding, and next one hot encoding. Then we have to dummy variable trap. We have to do 3 kind of steps to convert the string to numbers. But in pandas, there is a function called get dummies. Okay, and this get dummies. Sorry, before declaring it, I'm showing you something else. Yeah, so I'm just collecting the gender column from this data set. So X, I'm just calling the gender column. Yeah, I'm just separating the gender column from X, that this column, and I'm storing it a variable in a variable called gender. Okay, so our gender variable stores this column data. Okay, gender column data, and if I call gender, it's showing my gender column data. And then after that, in pandas, I have a function called get dummies. It synchronize the 3 steps, that is label encoding, one hot encoding, and dummy variable trap to a single step. So in pandas, there is a function called get dummies, and here we have to provide the gender variable I have declared. What it's gonna do, it's just converting the string kind of things to numbers. Okay, and also in 1 and 0 format. Get it? So here we know female, male, but it's converting into 0 or 1 or numeric kind of format. So here first one is female, right? So here it's declaring that first one female is 1 and male is 0. That means we don't require means from this data we get that first one is female, second one is also female, and last one second last one is male, and it also here showing that it's male, right? So another thing, just I'm pasting it here. Oh. Okay, so I'm just pasting it here and showing you that from this kind of data I can predict, or I can showing you that if first person is female, obviously this is not male. Means if it's already declared it's female, obviously it's not male. If it's not declared it's not female, obviously it's male. So from one column we can get that he's a male or female, or it's a male or female. So why we require 2 column, and 2 column also gonna give consume more power or more CPU power to get the model. So in get dummies there is a concept or parameter called here, yeah, drop fast. Okay, here the by default value is false. Okay, but I am going to make it true. But it is gonna affect, I'm going to show you. If I give it drop fast is true, so if so it's gonna delete the first row, and we have only one row information from which we can predict it's a male or female. For male or female we don't require 2 columns. One column is enough to know it's male or female. As soon as I click enter, yeah, the female column gonna omit, and we have only one column called male, from which we can predict that it's a male or female. Okay, so I am just saving this data in a gender demo variable kind of dummy variable of dummy kind of variable, and then I'm just overriding this X dataset gender, with this dummy variable trap and data. So here X gender, wait, X gender, we have to give gender, sorry, equal to gender dummy variable. Okay, so here it is not an error, it's just showing that the values are copying or overriding. It's not an error. Okay, so look, take a look here. Gender is in a string format, and if I am calling x, this is give this kind of output. Again, if I calling x, now it's overriding, and we can see that now gender is converted from string to number. Yeah. So now it's great for a computer, that number is great for me. So you do a great work, but there is another column which has some kind of string. So I show you to for understanding kind of purpose, 1 2 3 4 kind of steps to convert gender to numeric form. So also there is some one line of code in pandas. Same function get term is, we have to first we should check the documentation. Here we have to declare data, means which data set we gonna take, then which column we want to means in which column we have to apply the dummy variable trap, and then we have to declare the dog first. This is the third thing. So here I'm gonna give that x is our data set. In x we have a column called geographic, or I'm just copying it. Okay, so in string format. Okay, sorry. Yeah. Now in one line of code, the France, Spain, and another one is Germany. Yeah. The France, Spain, and German is in string format. In one line of code, it's converted into numeric form. And same kind of thing in male, female. If it's male, it's not female. Similarly, if it's not in France, obviously it's not in German, or obviously it's not in Spain. Or if it is in Germany, though there is no need, there is no data to tell us it is in France or Spain. So here I am also going to drop the first column. So drop first true. Okay. So yeah, so here our data set is ready and all are in now. You can see before we have a Germany, Spain, and France. Now the France get omitted and we have two columns like Germany and Spain. These two columns is enough to tell us that it's in Germany or not in Germany, in Spain or not in Spain, or in France or not in France. Okay, that's our data cleaning part. It's over, and you can see that all kind of data is now in numeric form, right? So this data sheet is great for our machine for creating a model. I'm just saving this data in a variable x final. Let's say in x final we have this data set. Okay. So our data set work is finished. Now we have to create our model. I am going to do the same thing from starting, that in Keras, from Keras I am a modular models. Yeah, models. I'm importing from Keras.models. It's sequential, right? And then I'm declaring model equal to sequential. Okay. Then it's empty kind of brain. Then I'm declaring from. I already tell you this concept. I'm just typing it from Keras dot layers. I'm importing dense. Okay, and after I told you sequence is just creating an empty kind of brain. Then in model we have to add the layers. In add function we have to create, declare a dense. Okay, and in dense we have to declare the number of neurons. We have to declare the number of neurons by units equal to, yeah, here we have to give the input set, means how many columns gonna come in my input data set. Okay, so we have a function to check that. Yeah, here in x final, if I check what is the shape of this final, this data set. So if I check, there is 1000 number of rows and 11 number of columns. It's also showing here. There are 11 number of columns and 1000 number of rows. Means there are 1000 or 10,000. Yeah, it's 10,000 number of rows. Means there are 10,000 different data, and in associated with 11 columns. Means these 11 columns are input for our first layer. So as they here it's 11 number of input, so I am also creating the 11 number of neurons. Then we have to declare, I told you that input step, how many number of input step gonna come. It's 11 and it's also in 2D format, I told you. Then I have to tell that activation function. Activation. I'm using the same kind of function that relu. Yeah, relu. Yeah, I declare units input set. Yeah, all set, and I'm just adding this. And if I model that summary, I added the first layer successfully. Then I'm adding the second layer. Okay, here don't require to declare input set, and I am giving unit number 10. Means in second layer I'm adding 10 number of neurons, and I don't declaring Cornon initializer or bias initializer because it's by default initialized with a function called glorod and zeros respectively. So I also added successfully the second layer. If I check model dot summary, summary function. So yeah, second layer is also added. So in first layer I have 11 input 11 units of neurons. In second layer I have 10 units of layer. I'm going to add another layer. So in third layer I am going to, here you also don't require input set, and here I am going to add 5 number of neurons. Okay, so yeah, and we have again taking model dot summary. Also added third layer. I am going to add, now I am going to add the final layer, right? So I am the first testing the code. In final layer, I told you if we have to choose units according to our output, our predictable data in Y. Here is, where is I? Y, yeah. Here Y, in Y we have two kinds of data set. How we can check by just I'm showing you. If in Y, if we ask why you have a uh, which count, you have a yeah, you have a function called value dot counts, which gonna help, which tell us how many number of categories you have and in which numbers. Here there are 7963 number of zeros and 2037 number of one. So there are two output, means this is a binary classification kind of problem. So here I am using 1 unit of neurons, and for I told you for binary classification. So here, okay. So our final model is created. If I also check summary, so I have I added 4 layers. First layer having 4 neurons, 10 neurons, 5 neurons, 1 neurons respectively. So before fitting the model, we have to compile it. Model dot compile. Okay, so you have to use optimizer. I'm using Adam optimizer. For binary function, I have to use loss, and loss is what is the loss function? Loss, yeah, yes, yeah, binary cross entropy. I'm just copying it and pasting it where, yeah, here. Uh, I declare loss functions. Yeah, I declared loss function. Then I am just initializing a matrix to show us accuracy. So in matrix, we have a column called accuracy. So our model is all set. Before fitting model, I have to give you some extra information. That is, if I give this data set to my model created, and it's great, but its accuracy gonna decrease. Why? Because these numbers are so 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 big kind of number, and they are also in separated by a different distances, means a large distances. So it's for this column our model have to choose some our model have to find some weight. For this column have some weight, this for each column it is should associated with some weight or bias. But if the number is if the number is so big, there is also you have to find same kind of weight like that is it's so big or it's so small, means we have to means we have it find different distances weights. So to get this we have to mm, means we require more and more neurons and more time. So to synchronize this to find instead of finding big number, we can solve it with a small weight. How? By synchronizing this data, means we can convert these big numbers to a small number, means the data set information don't gonna lose, but the value is gonna come into a synchronized manner. This concept is typical known as scaling. You also know this is concept is known as scaling. Let's take a example like we have different kind of boards exam. Let's say in a board in some kind of board exam there is total mark is 600. In some exam there is total mark is 1000. Let's say in another exam there is a total mark is 700, and someone achieving some mark from this, some mark from this, some mark from this. How we can tell which student is achieving more mark? Because it's achieving some mark from 600, this achieving some mark from 1000, and this student achieving some mark from 700. With just a concept, we calculate its percentile, then we compare. So what we do, we just synchronize this kind of data to a scaling part from 0 to 100, means we have to set all this data in a same scale, means 0 to 10, 100 means some maybe this is 80%, maybe it's 70%, or maybe it's 90%. But now we can compare this because these are in the same scale, right? These people are in the same scale. So what I'm trying to say, we should for comparing the data we should have them in the same scale, right? So similar kind of thing, to compare to find the weight or bias, I am just synchronizing the data or just scaling it. So from a scale on pre-processing, scalar preprocessing, we have a scaling function called standard scalar. Standard scalar. It's not common. Standard scalar electron. I spell it wrong. Sorry. Pre-processing. It's run successfully. So I have loaded a scalar called standard scalar. I'm just storing this standard scalar to a variable called any kind of variable. I'm just naming it scalar. Okay. I store this standard scalar function into scalar. Okay. After this, I am going to scaling my data. So I have a scalar dot fit and transformation is a function to fit my data to scaling part. Fit transform. Here I am going to give this my final data set called x final. Okay, so it's x final, and you can see that I have big number, but here it's synchronized to some kind of small number, but data is not loose here, just number is gonna synchronized. Okay, so I'm just and if there is number is small, so we have easy to find the small, we can find the small bias or small weight in small consuming the CPU and time. So I am just saving this data to my variable called x scale data sd. Okay, so that's it. Our model is created, our data sheet is great. So I'm just fitting the data model dot fit x. If we also take the documentation, we have to give x and y, and there is the concept called epoch. I told you in the twins example that if we acquainted with data more and more, the output or prediction gonna increase, its accuracy gonna increase more and more. So epochs is that kind of thing. I'm going to tell you. First, we have to give the x data set, that is x scaling data. Then we have to give y. Then here is a parameter for epochs. Epochs means how many times we're gonna again and again train the data or fitting the data to our neurons. That is, in every set of time, how many times we again and again fitting the data to our neurons. Means just like in twins example, their parents are more acquainted with their children, so they can distinguish which one is Tom and which one is Jack. And same thing, more and more we acquainted with data, more and more accuracy gonna come. So all set. If I run it, yeah, you can say the accuracy is performing well. It's gonna give us yesterday. In yesterday model, we get accuracy up to how much?
I think it's 73%, Swag.
Yeah, so here its accuracy is 86%, right? So neural network is working great, right? So our accuracy is gonna increase. And if I show you in a graph, there is a concept model dot history. Okay, this variable store the all loss data, means our loss function data and accuracy data. Okay, then I'm just saving the loss data. Okay, this is our loss data. Means see here, our loss, first loss is something around 0.51, then gradually our loss get decreases and come to 0.33. Same data are saved here. Okay, and if I plot if I store this value in a variable called, let's say, loss, sorry, it's loss. So a loss, and in pandas we have a function called loss dot plot, and it will plot a graph for us, but it will throw an error. Why? Because if we check the type of loss data loss variable, it's list, but a plot is a function of pandas dataset. So I am going to convert this list to pandas frame. So in pandas there is a function called data frame. In data frame we have to keep this variable. And yeah, now this number is converted into a pandas format. And also if I check type of this variable, sorry, I have to save this data in a variable, let's say my loss. So if I check the type of my loss, okay, it's now in pandas format. Okay, so now if I plot the graph my loss dot plot, yeah, it shows us the graph. Means initially the error is 0.52, then it's gradually decreased, and after some time the error gonna decreasing so negligible manner, and finally it's up in 20 epochs. It's gonna find it great accuracy. Okay, we can similar way we can plot the accuracy graph. So if we in model dot history we have the accuracy data, yeah. So I am going to save this data. I am going to save this data in a variable called accuracy, and accuracy also in a list format type accuracy. So I have to convert it to that pandas data frame. In pandas data frame, uh, what is accuracy? I'm just saving to my accuracy. Yeah. So now it's converted to pandas data frame. If I plot graph now, dot plot. Yeah. Also, my initially my accuracy is 79%, around 79%. Then it's gradually increasing, and after some time it's gonna stop. Okay, I told you also 85 to 90% accuracy is great for our model. Okay, that's it for today. Oh, so if any queries you have,
So, guys, if you have any doubts, then you can ask him right now. Priyanka, are you there?
Yeah, I'm there.
Uh, first 6 lines of code. Uh,
means
Which first, can you share the screen again, Suhag? I guess he's asking from that code part you just put it
I
right now.
think he don't able to understand first 6 lines of code.
which 6 line can you
Uh,
tell me?
I think
Which is dataset? Converting this dataset or anything else?
Can you please specify which 6 lines of
yeah, that
converting
is
the data?
yeah. They is asking about that is data insertion. CSV
Okay.
file.
Uh, what?
That is the standard practice actually, guys. You have to do it every time while importing data from your local system to the Jupyter part. Uh, there is nothing, any logic behind that part.
Which? Okay.
About deciding the units.
Yeah, you can. There is no specific functions or trick to choose the units. More and more, you work on the data set or typically there is some neurons created on in your mind that there is an intuition and you are comfortable with how many neurons are gonna create and yeah, I forget something. To check how many neurons or units gonna use, we have manually check first. We need add 5 neurons, check it's give accuracy or not. Then we add 10 neurons, but we have to do it manually. But there is a also integration kind of thing. There is a DevOps concept, which is use of CI/CD pipeline or Jenkins means automation tools. Jenkins or our what
GitHub Action.
yeah, GitHub Action. Those are automation kind of things which instead of manually we add the neurons, these tools are adding neurons automated way, and this integration is typically known as MLOps, machine learning plus DevOps, and this is getting the vast in market nowadays. So there is no formula to how many
Yeah.
neurons we will take.
Actually, you have to if you want to manually do it, then you have to do it by hit and trial method. There is no specific ways to calculate this. I can say one suggestion you can divide it in the ratio of two. Like if you used 128 units in first layer, then you can use half of that neuron in the second layer, and then half of that in the third layer. That is actually a standard DSA practice. By that way, the model can perform better. But basically, there is no any specific way. Like Suhag has already told you, you can use MLOps concept. Like there is CI/CD pipeline. These are all the automated platform. Like if your accuracy is not good enough, then it automatically changes your all the input layers and all that part, and uh, again 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 compile the model. And accuracy till that, if accuracy is not satisfactory, then it repeatedly do all this changing part, and it do it by manually. No human intervention is there. All these concepts are higher concept, that is MLOps concept, machine learning with automation, like DevOps concept. But till now there is no any specific way you can do it manually. There is no formula to do it manually.
Yeah, exactly. Like Lakshman mentioned right now, like we will be first layer we'll be taking it as equal to the number of columns. Then you can just go on dividing by half, and it's just the trial and error method for right now for us. But if you like go on studying MLOps, Jenkins, you have mentioned about that, right? So
And
it's a
GitHub,
kind of automation. Yeah, it's a kind of automation thing which will like you don't need to like give all those efforts. You'll be able to understand that unit thing. And yes, Nishikant Parida, he is asking the first 6 lines of code from the data set selection part.
yeah.
Data set selection part. So can you
So
share your screen? Which code his data set selection part he's asking?
Again, I am just revising the
You
code.
can tell them in short, like
Yeah,
it's
yeah.
already right.
First, we have import the pandas data, pandas library. Then pandas web function read CSV to read our comma separate file. Then by this function, I read the data set, and now this data set is in this tabular kind of format. Yeah. So are you talking about why don't take this row customer ID surname or anything else or coding part? Do you talking about concept or coding part?
He's talking about the code for 6 lines of code.
Code.
You keep on sharing, I guess, that
Yeah.
importing
Yeah.
pandas data set is equal to pandas dot read CSV. Are you asking about that, Nishikant?
So I just declare here the tabular format of that in the pandas format. Then I separate the dependent variable, that is our prediction variable is exited last column. I separated it from our dataset and storing in a variable called y. Then similarly, I eliminate the row number, customer ID, and surname because it is not gonna affect our output. Then after eliminating the columns, I just load this the other required columns to my variable x. In x, we have some data in string format, and we have to change this string to numeric format because computer always understand number. It's compatible with number. It is not gonna any kind of situation, it is not gonna try to understand the string kind of format. So we have to convert the string to numeric format. So I do some
like
function.
we cannot apply mathematics to a string, right? So we
Yeah,
have to
Okay, he
convert the
got
string
it.
into a number.
Shuhag, he got it actually. He
yeah,
was asking, was
yes.
separating the that x and y part. We were
Uh,
separating it to inputs and output. Like for the
uh,
independent features, we were keeping it in x, and the target variable we were keeping it in y.
that is actually a pandas operation. We have to work on pandas.
So he got it. Okay, fine. So like I think we have already near the end of the session. So we guys have already like shared the link of the notebook of the Google Collab with you. Let me share my screen. It will be ending the session within 2 minutes, so you guys don't need to worry anymore. So yeah. So what I'm trying to say is whatever Shuha coded, that live coding thing. Yesterday we did up to this. All these things we carried out. We did up to machine learning. Mm, yeah, up to this. This is the day, like day two. Whatever he has coded, basically it's the same thing. Uh, but the only difference here is in the pre-created notebook, the accuracy here is 0.88 because we have like because he was live coding, so he could not like add certain things like this outlier removal thing and the oversampling. Since we have like feeded the oversampled data, and after removing the outliers we have fed it to our model, so it kind of accuracy is 0.88. So basically that was the goal. Like you can see same data, same set of inputs we were providing to the machine learning model, and the accuracy was 0.73. And the same set of inputs, we didn't do anything extra, we are providing it to deep learning model, and how the accuracy is changing, like it's 0.88. So that was the goal of today's session. Like we were trying to show how deep learning is improvising our performance. And so that's it for today. Like we took longer than yesterday, but yeah, live coding tha, to I guess you guys would not have got bored, because that was interesting part. And
And
so yeah,
from the
Lakshman.
from the from that Collab notebook. If you have any doubt in future, then you can easily freely contact
Yeah,
free to contact us.
you can freely contact any one of us. We'll be more than happy to help you.
No, help you.
And
So
from my side, there is a humble request for my effort. Go to my LinkedIn profile and give me endorsement. Okay.
okay, fine. This
And if
it's
you
not the
have
promotion. It's not your
any doubt,
personal
any
promotion
kind
site.
of doubt, you can ask there or DM me in
Oh,
LinkedIn.
okay, that
Thank
was really cool. Okay, fine. So you can yeah, you can search us
Priyanka,
on link.
just
Yeah.
give them a brief info about tomorrow's session.
Yeah, regarding tomorrow's session, it will be at 5 o'clock tomorrow. So it's going to be the final day, and it's the most important session I can say, because we will be having our speaker, Miss Usa Ranga
Yeah.
Raju with us. She is she's you can say motivation for all of us, so you should not miss the chance of talking to her. You will really get inspired to work in this field, and like it's a lifetime opportunity, once in a lifetime opportunity. So you should be there anyhow. And we will also be sharing with you the details of the competition. So tomorrow's event is a must thing, and you must stay till the end. And that won't be that long, because we'll only be just launching the competition. We'll be having our session with the speaker, and that's it. So
And
yeah.
in competition, if you well perform well, then you have you get some goodies from our club.
Yeah.
Yeah, from Google.
Goodies are based on the performance basis, guys. Okay. So most make sure you join tomorrow and perform
Yeah,
well
to know
in
the details about the competition. So yeah,
perform.
that's it for today. Thank you everyone for
And
staying with us till now. It was great interacting with you all. So hope we'll be seeing you. Is the certificate provided for? Well, I'm not sure about that, but we will be contacting our team, and we will let you know. So yeah, so see you tomorrow, guys. Thank you.
thank you.
You
Okay.
can start leaving now.
That's it
Bye.
for today. Bye. Take care.
Thank you. You can start living, guys.
Great session it was. Yeah, thank you, Pratyush. You all stayed till then. We felt great about that. Thank you.
Thank you.
Sebas, thank you.